Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fadil Firdaus, and today in this video I will be presenting to you on my design of the rehabilitation center. So the name of my rehabilitation center is Pacific Shark Rehabilitation Center. From its name, we can already know that Pacific is a rehabilitation center that is designed specially for bamboo sharks which faces the brink of extinction. This center was inspired by the location of the site itself, which located beside the Cerok Paloh beach. So from that, this is when I came out with the design wave. So the wave is applied on the design. The concept are then translated into few architectural principles, which are repetition, hierarchy, rhythm, and symmetry. Instead of taking the direct shape of the wave, I have decided to take the principles from it and also the behavior of the wave itself, and then I applied it into my design. Let's look at my key plan, which is located at Kuantan, and the location plan is located at Kampung Hijrah. The site that was assigned to me is Site A, which its dimension is 50 meters by 80 meters. Now let's look at the site synthesis. The first synthesis is to preserve the greeneries around the site to help passively cooling the area. The second synthesis is to propose a road to the entrance to the site. As you can see from the diagram, you can already know where is the entrance to the site. The third synthesis is to put hatchery area close to the sunlight, because the sharks needs to get a lot of sunlight. The fourth synthesis is to make use of the air which came from the north and east and make openings on each side of the building for cross ventilations. The last site synthesis is to make full use of the best view, which is the sea. Moving on to the case study. So the first case study is I studied about the bamboo sharks itself. So my synthesis is to provide the correct tank size for the sharks, starting from the eggs, the juveniles, and the sexually matured sharks. Next synthesis from my case study is to use the correct lumen and type of light for each spaces in the rehabilitation center. And the last case study is about materials, and my synthesis is to use non-toxic materials such as concrete and silicone coatings that are harmless to the marine creatures. Next, we will be looking at the precedent study synthesis. So the first synthesis is I will segregate between the public and private spaces. The next synthesis is to put the souvenir shop near the exit or entrance to the rehabilitation center. As for a shark rehabilitation center, souvenir shop is very important because it will raise awareness to the visitors. The last precedent study synthesis is to put a simple and directive circulation to ensure the smooth visit from the visitors. Now let's look at the site plan. Starting from the entrance of the site, both visitors and workers will enter the site from here, and on the left side is the private parking, and on the right side is the public parking. And if they go straight, they will meet the drop-off point, and both of them will exit at the same part here. And on the left side of the site, you can see that there is a loading area. Moving to the design development. So the first step is the main axis was taken from the best view, which is the sea. So the orientation of my building will follow this axis. And then the second step is the second axis was taken from the wind that is coming from the north and the east. Like I said before, the orientation of my building will follow the axis. The third step is when I applied my concept, which is the wave. For your information, wave always came in sevens. So there will be 7 main space or 7 shapes forming on my design. And all of that forms is following the axis. And the design language that you can see here is a bonefish-like structure. Like I said before, I am designing for a shark rehabilitation center. So that is why I am following the bonefish-like structure here and also using the concept wave. The next step is when I applied hierarchy. Like I said, the wave always came in sevens, and each seven of the wave, it is getting bigger and bigger. That is when you can see that there are hierarchy in my design. And the last step is I opened up the spaces so that the main axis in the middle is not blocked by any spaces, and it will highlight more on the view of the sea. Now let's look on my first level floor plan. So both visitors and workers will enter the building from this part here. And also you can see that there are strong axis in the middle here, straight to the view. So the next thing the visitors do is that they enter the briefing room here, and after they completed hearing any brief information about the bamboo sharks, they will go out through here and they will go straight to the exhibition area. So in the exhibition area, the circulation is very simple. In the middle there are fish tanks, so they will go surrounding the fish tanks and they will exit through the same entrance here. Then they will cross the building to this part here, which is the laboratory. So in the laboratory is where the scientists put the egg case for the sharks here, and the visitors, they can look at the egg case from outside of the window. And the next thing they do is they will go to the hatchery area, which in the hatchery area they will see the juveniles of the sharks and also a sexually matured sharks which are ready to be released to the sea. So like I said before, the circulation of my design is very simple and directive. So starting from the lifetime of the sharks itself, which is from the eggs, and then they will move to the juveniles, and then they will move to the sexually matured sharks, and then which are ready to be released to the sea. And that is why the hatchery area is located close to the sea and also on the east part, because it will gain a lot of sunlight. For your information, sharks that gain a lot of sunlight, they will grow faster compared to sharks that did not gain enough sunlight. And the last stop of the visitors is they will go to the cafe, and in this cafeteria is where there are a kitchen and also the store for the loading area and also an outdoor eating area. So from there they can enjoy the view of the sea, and they can also enjoy the breeze of the wind coming from the north. Now let's look at the second level floor plan. So they will go upstairs at this staircase here, and then on the second level floor they will have a musola and also a library. So this both part here is located near to each other because both of these spaces, they required less noise and a lot of peace. Next is on the most far side is the office, in which the office have a meeting room and also the admin here, and they will all can look at the beautiful view of the sea. On the middle of the building is a steel beam which hold the structure of the roof, which the roof is I'm using a tensile membrane roof. So this beam will hold the cables that is stretched from the tensile membrane roof, and also this beam will also act as a highlighter for the strong axis in the middle of the building. Looking at the northwest elevations, the tensile membrane roof for structures forming the shape of the weight, and the steel beam in the middle is portraying the shape of the shark's fin. Both of these elements will portray the sharks swimming in the middle of the ocean. I will now show you all of the elevations and also the model of my buildings. Now let's move on to the construction details. Starting from the foundation. The foundation that I will be using is a pile foundation. This is because this site located at a soil that are unstable. So using piling or a friction pile is the most suitable foundation. As you can see, I will be using a concrete pile cap and also the piling. So at the floor, there will be a rigid insulation, and the type of flooring is a concrete floor slab. And also, I will be using a concrete beam since the construction of my building is a simple post and beam construction. However, the roof I will be using is a tensile membrane roof, which you can see that there will be an upper membrane and also covering membrane and ring beam. So for the details, you can see at the engineer's detail. Now let's look at the lighting design strategies. So the first area, which is the cafeteria, the lighting method that I will be using is suspended lighting, which it will be used for eating space which needed less ambience, and LED lights that creates a better color index. The next lighting method is direct mounted lighting, which is going to be used especially in kitchen, that gives higher brightness and it is suitable for the working area. As for the ambience technique, I will be using a dimmer system for lighting brightness to create soft environment, and also I will be avoiding using fluorescent lights and LED lights to create the environment with better color index. So as for the energy efficiency in the cafeteria, I will be using the daylight by providing windows and openings, and also I will be using LED lights which consume less energy. So the required lumen or lux for the cafeteria is 200. Next space is the exhibition area. So the lighting method is I will be using an angled recessed lights which installed above informative boards on the wall around the exhibition area to help the visitors read clearly. And then I will be using an integrated lighting method with concealed lighting, and it will be used as the general lighting for the exhibition, and it will bright up the wall. So the ambience technique for the exhibition area is also I will use a dimmer lights around the exhibition area except for informative boards to create calming and peaceful vibes, and also a wall washing techniques to give texture of the wall around the exhibition with no direct lights. As for the energy efficiency of the exhibition area, I will be using LED lights and also a motion sensor. When the exhibition area is free, this sensor will switch off the lights or making it dimmer, which then will be less energy consumption. And the required lumen or lux for exhibition is 150.